lottery, a player picks 6 numbers from 1 to 24. If the player matches all 6 numbers, they win $30,000. Otherwise, they lose $1. What's the expected value of this game? So remember, expected value is related to the probabilities and the values of each probability in a sum. So we need to figure out what's the probability of a win here. And a couple of considerations. One, are the numbers replaced or not? So with or without replacement on the numbers. Like if I draw a 2 as one of the numbers, can we get another 2? The second consideration is, does the order matter? So if the sequence of numbers, say, was 2, 5, 21, 17, 6 numbers, 3, 15, supposing they have to be different, then if the order doesn't matter, then a match would be as if that's what I think it's going to be, and it ended up being 3, 21, 5, 15, 2, 17, right? Same numbers, different order. So for this one right here, I'm going to assume that it is without replacement. So that means we can't select a 2 and then another 2, and that the order does not matter. So that these 2 here are the same. They're both a match. Let's see, the other thing I'm going to assume here is I have to pay $1 a play, so my win is actually the 30,000 minus 1 if I win. So that would be $229,999 is my actual net per win. So with these assumptions, once I have that probability of a win, then my expected value would be that times the 29,999 plus the probability of a loss. Well, that would just be 1 minus the probability of a win. And the value of a loss would just be negative $1. So all this hinges on me figuring out the win. All right, so I'm not replacing the numbers. So if I count how many possible sequence of 6 numbers there can be, we count that out. The first number, there's 24 numbers to choose from. Once we pick it, we can't pick it again, so there's 23 for the next one, and I have 6 slots to fill. So 1, 2, 3, 4, 5, 6, 2, 1, 20, 19. 1, 2, 3, 4, 5, 6 slots. 19, 20, 21, 22, 23, 24. Now, if I take this product here, then these 2 are different options in that. How many different ways can we reorder those 6 numbers? Well, there would be 6 times 5 times 4 times 3 times 2 times 1 different ways we could reshuffle those specific 6 numbers. And so this quotient right here is going to be the total number of possible matches for a sequence of 6 numbers, 1 through 24. And that turns out to be a combination. That is 24, choose 6. So let's test that on the calculator and then find our expected value for this lottery. So the first way I thought about it was 24 times 23 times 20. Oops. Wrong button there. Times 2 is 21 is 20 times 19. So I have 1, 2, 3, 4, 5, 6 numbers, 19, 20, 21, 22, 23, and 24. That's if order mattered. I'm going to say order doesn't matter, so I have to divide, by the way, the number of ways we can order 6 things, which is 6 times 5 times 4 times 3 times 2 times 1. So if I type those numbers correctly, looks all right, then I get 134,596 different possible outcomes for this lottery. So 1, 3, 4, 5, 9, 6. Let's double check the combination function on the calculator. a second key on your calculator. Line combination, 24 things, selected 6 at a time, I get the same value. Okay. Now the probability then I want is 1 over that. So I'm just going to take 1 and divide by that. I'm not going to do that here. Divided by that answer. So that right there is my probability for a win. So my formula then is to take probability for a win times the amount I win, plus the probability of a loss times the amount of my loss. And that is the expected value of this game. So, up that previous answer, so I'll have to retype it, times the 29,999 plus parentheses 1 minus that probability above is the probability of a loss, the complementary, times the value of the loss, parentheses, -$1. And I get an expected value on this game is about 78 cents to the nearest cent. So again, this is a dollar amount because I'm working with these dollar amounts of winning or dollar amounts of losing, and the expected value is the long-term average of this particular lottery. So after millions of people play it or an individual plays millions of times, what on average did they make per time? And we're finding over the long haul, the expected value for this game from the player's point of view is negative 78 cents an hour. So the average payer loses 78 cents, even though some people win 30,000 in this game right here, which means on average per person, the lottery commission makes 78 cents per person, even though they have to pay out $30,000 occasionally. So that is expected value. And this was a complicated one in terms of counting the possible ways we could find a match.